Thanks for joining us today. Today we're going to talk about BACnet, a couple different forms of BACnet, including BACnet IP and BACnet MS. So once again, thanks for joining us today. You'll have the opportunity to ask questions at any time just by typing in those questions at the GoToMeeting control panel. Let's go ahead and get started. All right, let's take a look at our agenda for today. We want to talk about BACnet. What is BACnet? Going to talk about the building automation market in general, a little bit of history behind BACnet, how it works, how you might use a Horner OCS All-in-one Controller in a BACnet application. Horner OCS is our product name for our all-in-one controllers. For those of you who are not that familiar with Horner and our products, we are located in Indianapolis, Indiana. And we are a US manufacturer of automation. After talking about how you can use our products in a BACnet application, we'll give you a demonstration on how to configure those with a little bit of programming in there. And as I mentioned earlier, opportunity for questions and answers at the end. Okay, what is BACnet? Okay, BACnet stands for Building Automation and Control Network. Today, it is certainly the most popular network for building automation installations. Like the industrial market, this is a segment which has traditionally featured a lot of proprietary networks, but BACnet has done a pretty good job of grabbing a significant portion of new installations for sure, and we're going to talk about that. So the building automation market in general is growing. So a market study said that approximately 75 million was the size of the market in 2019, and it's projected to grow to approximately 120 million by 2024. Now, that growth is in part due to a focus on energy savings and energy conservation, because certainly one of the goals of building automation is to manage the devices that are used to power a plant or a facility, and those devices require energy. So by better managing and measuring what's going on with those resources, it's much better and easier to save energy. So that's one of the driving factors behind building automation. In terms of how successful BACnet has been in acquiring the interest of those who are installing and specifying building automation. In 2017, so just a couple years ago, BACnet had already attained approximately a 64% global market share, with 81% market share in North America. And actually, I've got a typo there, I believe about a 51 or 52% market share in Europe. So overall, globally, about a 64% market share. That's pretty good. BACnet was created and is managed by the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And it is promoted by BACnet International, an organization that was created a few years ago. So if we take a look at what BACnet looks like, you'll see that you typically have a building management system, which is a computer system. You have a variety of manufacturers that support those, people like Johnson Controls, Honeywell, Siemens Building Automation, those sort of companies, Schneider. So they supply building management systems. And the whole goal there is, with BACnet at least, is to make sure that equipment from a whole variety of manufacturers, including companies like Horner, their equipment can be residing on the building and automation network, allowing facility managers ultimate freedom in selecting the products that are the best for their application and allowing everything to communicate over a common network. If we take a look at where building automation came from, again, it's very similar to where we have traditionally been in the industrial market. And that is where you have proprietary solutions that were kind of the backbone of what customers typically use for automation. And that was true and has been true in building automation as well. Proprietary networks from people like Johnson Controls, Landis & Staffa, which was acquired years and years ago by Siemens, a network called Lawn Talk, which was a proprietary echelon system. While those systems still certainly exist in the marketplace today, BACnet has done a good job of supplementing those and replacing them in a lot of cases. From a timeline standpoint, as I mentioned at the top of the broadcast, BACnet is not that new. It was first talked about in 1987. It was first released as an ANSI standard in the mid-90s, adopted as an ISO standard in the early 2000s, and BACnet International was formed in 2005. So that's a good amount of time that has passed since this network has been formed. But it has continued to gain momentum, and they've continued to update it as time has passed. If we take a look at the BACnet model, for those of you who watched the Ethernet IP session that we had a few weeks ago, you'll notice that Ethernet IP, which certainly followed the 7-layer OSI model, has certainly quite a bit in common with BACnet from that standpoint. Although one thing that happened with BACnet is they collapsed that 7-layer model down to 4 layers, really. And they've defined, like the ODVA, the effectively organization that manages Ethernet IP and DeviceNet and ControlNet and those networks, like that group, the BACnet folks have made sure that they supported multiple media layers, so that not only can you support a protocol over Ethernet, for instance, they actually have a couple different ways of doing that here, but BACnet really is one of the most flexible networks in terms of the physical media that is used for exchanging data. They support officially 7 different media layers with this protocol. Now, that being said, there are 2 that are overwhelmingly the most popular, and that is something called BACnet MS TP and another protocol called BACnet IP. So those really are what get a lion's share of the installations today, especially BACnet IP. BACnet MSTP is a RS-485 based network, so it has the disadvantages of not having the really the throughput and the speed that you can achieve with BACnet IP. It's a lot more, I would say it's a lot more difficult to configure. There's certainly a lot more parameters to adjust potentially. And so I think most new installations certainly are going the way of BACnet IP. And legacy applications where maybe they don't have the Ethernet infrastructure, you'll still find a lot of BACnet MSTP out there. One thing that BACnet does very well is what they call interconnecting networks. So with BACnet, you can very easily have a traditional BACnet MSTP type network out there. Again, that's RS-485 based, but that can be routed to a full BACnet network, maybe BACnet IP over Ethernet. Mixed in there, you could also be having actually multiple segments or multiple subnets, if you will, of BACnet IP, just using standard switches, Ethernet switches and routers. And then it's even fairly friendly in terms of supporting things like gateways. And you can certainly use one of our products as a gateway to take a legacy network like Modbus, for instance, and exchange data with those sorts of devices that may already be installed in your facility and get those up on BACnet as well. Now, for that scenario where you're interfacing with a third-party network, there is data translation that's required, but that's something that a device like the Horner Operator Control Station can handle. All right, so now let's start talking, just like we talked about with Modbus and with Ethernet IP, we talked about kind of the model for the network and how data is represented. We're going to do the same today with BACnet. So like Ethernet IP and the SIP protocols that we talked a few weeks ago, BACnet does use an object model. Okay, so it's based around devices that have objects and those objects that have properties. So let's dive in. Let's start with BACnet devices. What is a device? Well, a BACnet device is a collection of a set of objects. And one thing that BACnet has really done is they have identified and defined a whole slew of objects. So that blue table to the right there on that slide is showing, as of the 2012 spec, the 54 different object types that were predefined. Now, that being said, most devices fall under the basic device object types that are listed first there in the top left corner. So even though there's a lot of flexibility and a lot of potential detail and different types of objects, a lion's share of the devices out there use the basic device object types. So the object type, what that defines is it defines a list of possible properties for that object type. Okay, so again, on our top level, we have a device. That device is made up of a collection of objects, and within those objects are potential properties that those objects can contain. Now, we do mix a little bit in our nomenclature between talking about object types, which we're showing there in the table, and objects. An instance of an object type would technically be the objects we're talking about with BACnet devices. So for instance, an object type is an analog input. That's an example of an object type, an analog input. But a BACnet device might have several analog inputs or several instances of analog inputs. So it's one, in that case, you might have one analog input type, object type, but you may have 8 instances of that same type. Now, if we take a look at the Horner products that reside on BACnet, we effectively are a device that are made up of 7 different object types. So every BACnet device that's defined, including our product, has to support the device object. But in addition to that, we support 6 other objects, or object types, I should say. Analog input, analog output, analog value, binary input, binary output, and binary value. So that is a quick look at the object types that are supported by our products. Now, in addition to defining objects and then the properties that reside within those objects, BACnet also defines what they call services. And these are services that really define how devices communicate with each other. Okay, and just like there's a whole slew of predefined objects with BACnet, there are a whole slew of predefined services as well. And those are organized into 5 different classes that I have listed there. Okay, alarm and event services, file access services, object access services, which are by far the most common, remote device management services, and virtual terminal services. And the virtual terminal services are pretty much obsolete because they were based around text-based devices back in the day. So again, there's a whole slew of services available. And then services within BACnet follow the client-server approach. So one device, the client in the transaction, would send a service request, and then the server, which is the other device in the transaction, is going to send a service response. From a Horner standpoint, we just quickly have highlighted there the services that we support as part of our BACnet interface. All right, now to ensure interoperability between devices, one thing that BACnet does is, while it defines a device in general as a collection of objects, it does categorize devices into different types. Okay, and they have actually 7 different types of seven different types of devices which are predefined. And these range from the extraordinarily simple, like a BACnet smart sensor, which might be nothing more than a temperature input, all the way up to the full building management system, which might be a BACnet Advanced Operation Workstation. So again, they have 7 different categories or device profiles that, I guess you could say, categorize different devices on BACnet. Now, from a Horner perspective, we are a BACnet application-specific controller, but you could also apply our product, even though it typically is not. You could also supply our product as a BACnet smart actuator or even as a BACnet smart sensor. But most typically, it's going to be applied as a application-specific controller. All right, now when you talk about interoperability between devices, okay, we talked about the fact that they classify devices into different categories, and how those categories, I guess, are really specified is through a couple more concepts that we have to review. First, called interoperability areas, okay, the areas of sharing data between devices, alarm and event management, scheduling, trending, device and network management. Those, again, are 5 interoperability areas. And then that concept is also used hand in hand with what's called a BIB, a BACnet interoperability building block. Okay, and that is a collection of BACnet services. And those are prescribed in terms of whether that service is being utilized by a device where they are a user or a client, or whether they are a provider or a server in that particular case. And these are abbreviated. You can see in the right there that you start with, you know, as a kind of a nomenclature that's used for BACnet interoperability building blocks, or BIBs for short. They combine abbreviations for the interoperability area, the services, and then how that is supported by the particular device as either a client, often called an initiator, or a server, sometimes called an executor. So again, these are various definitions that really help ensure that BACnet devices can share data. Now, where all this comes together, and again, this is a little bit of a level of detail that you really don't have to know extremely well. Really, these are just concepts to try and understand. This chart basically shows across the top in columns the 7 different device profiles, okay, for the different types of devices or classifications of devices. And then down in rows are the interoperability areas. And then within each cell are 1 or more BIBs that, again, define the interoperability areas along with the services that need to be supported by each type of device for it to be interoperable with other devices. So that's really what this all comes down to, interoperability. Now, from a Horner perspective, once again, we are an application-specific controller, which means that there are a minimum of 5 BIBs that we must support in order to be conformant as an application-specific controller. And you can see to the right of the application-specific controller, you have 2 columns. You've got a smart actuator and a smart sensor. And as you can see, those devices are quite a bit less sophisticated than an application-specific controller, but so that tells you that a Horner controller could act not only as a ASC, but also as a smart actuator or even a smart sensor. But of course, that would the product does have considerably more horsepower than what you would use just for that. Okay, now to kind of summarize the functionality that you'll find in our product as it relates to our BACnet server capability, because remember, we are a BACnet server. We are not managing the entire network. We are not managing a building. We are typically applied as a device in the building, such as a chiller or controlling an air compressor, performing lighting control or lighting automation. Again, we're acting as a server, whereas the building management system is going to typically act as the client. So if we kind of summarize the capability of our OCS product, in that first chart there, we show the different objects that we support with BACnet. So a Horner controller supports, of course, the device object, which is required by all BACnet devices. In addition to that, it supports analog value objects, anywhere from 0 to 5,000 of those. Analog input objects, anywhere between 0 and 256 of those. And then similarly, analog output devices, or I'm sorry, analog output objects up to 256. Digital values up to 1,000. digital inputs up to 256, and digital outputs up to 256. So what that means is that as an OEM or a machine builder who is, let's say, building chillers that they are selling into a market where BACnet is an important protocol for their customers, a chiller manufacturer would have the opportunity to pick and choose the objects that they need among those listed in order to provide the data and the interface needed to monitor and control a chiller. So that could be anywhere from just a few points with just a few objects, or it could be very extensive if that was desired. And then as we continue from left to right with the additional tables, you can see we have a list of all the services that we support, all the device parameter, or an example of some of the device parameters that we support for our device object, where we can report that this is a product that's manufactured by Horner APG, present the model name, that sort of thing. And then we also show in the last chart kind of the highlights of some of the device parameters. I'm sorry, some of the, not the device parameters, that's a typo, but some of the IO object parameters, where you can see things like present value, for instance. Okay, so hopefully that summarizes relatively well the different elements available with our products and BACnet. Okay, now let's talk about how you might configure one of our products as a BACnet MSTP server. Okay, so keep in mind that BACnet MSTP is based around RS-485. So most commonly, that is going to be a two-wire half duplex network, very similar to what you might find Modbus running on these days, running at a relatively slow baud rate. I mean, you're going to be talking 100K or less, where the default is 9600K, and the most typical might be 38400. So this is really almost a legacy network. Now today there's a lot of it out there, but again, for new installations, more than likely, you're going to select BACnet IP instead. Okay, but let's say that you are installing our product as an MSTP server. The first step is you do need to match the port configuration with what's happening on the network, getting the baud rate, parity, etc., setting that to appropriate levels. Now, if you're using Service Pack 9.9 Service Pack 3 or later, then you have the ability to enable, to start, stop, and reset the BACnet interface on demand through the use of a disable bit. So that is something you can configure, again, in the Cscape configuration. And we'll show you where all these configuration options are located with a live demo here in a little bit. We also have a status register that you can configure. So you can assign a variable to that that will give you the real-time information to let you know that you're talking successfully on the network, or maybe you're not. So after we configure on the network level, again, which is where we configure baud rate, enable, disable, etc., then we go into the device level. And with MSTP, there's a little bit more to configure than you'll find actually even on BACnet IP. So the first thing that you'll need to configure, that of consequence at least, is a BACnet instance ID. So this needs to be unique on the network. So the default is typically 1, but that may not be a great choice to use. You're probably going to want to use something that's not quite as common as 1. But again, so the first thing you have to configure is a BACnet device instance ID. And then you've got a whole slew of device options for configuration there. Now what those are different parameters that can be used for adjusting the token passing that is happening with BACnet MSTP. Token passing networks used to be extremely common, and they've become a whole lot less common over the last several years. So there's a lot of adjustments that can be made, but in general, most of the parameters can be left at a default level. Now, one thing to keep in mind is that as an RS-485 network, BACnet MSTP is not fast. You could be looking at scan rates that are several seconds long here. Okay, so this is typically for gathering things like temperatures and pressures, and not things that happen on a very fast basis. So to optimize performance, even with a relatively low performance environment, there are some hints that we can give you, or some approaches that you should take. While even though you could have, in theory, 127 devices on a BACnet MSTP network, that would probably be a really bad idea. You're probably going to want to keep it to 16 or below just to have a reasonable response time. Also, MAC addresses, which are kind of the node IDs, if you will, of the network, they can also have some very large numbers, but because it's a token passing network, you're better off keeping all those numbers low and consecutive so that the token can be passed efficiently, okay? And then they have a parameter called max master, which also can be adjusted, and if it is set pretty much at just above or at the largest address of the device on the network, that will also help keep the token passing performance at an optimum. So those are just some hints for BACnet MSTP. But again, this is configuration on the device level. So at the network level, we configured the baud rate. At the device level, we made some adjustments to some of these token passing parameters, set the MAC address, and set a unique device instance ID. Finally, the final step is to configure which objects and how many of them that we want to allocate for our device, which is going to be sitting on BACnet. And this process is the same whether you're talking about BACnet MSTP or in a few minutes when we're talking about BACnet over Ethernet or BACnet IP, okay? So from these numbers you can see here, you have the ability to allocate a whole bunch of instances of analog values, digital values, etc. And if you're talking about a relatively slow RS-485 network, you're probably going to want to keep those to a minimum for sure. Okay, otherwise you could be looking at really kind of lame performance. Keeping in mind that with building automation, you're not always needing the highest performance levels. Okay, so that's a look at configuration. And again, we're going to be doing a live demo here shortly, but that's a look at configuration of BACnet IP on RS-40, or I'm sorry, of BACnet MSTP on RS-485. Now let's take a look at BACnet IP. Okay, so just like with MSTP, we do have network level configuration that we have to do, but instead of configuring baud rates and things, this is where we're configuring our IP address, net mask, etc. And then from the LAN configuration area, which is where those are all set, at the bottom left, you'll see a downloadable protocol area, and that's where from the pull down list, you can configure or you can select BACnet IP server as an option. So that's all you need to do on the network level. Set the IP address, the net mask, and then select BACnet IP server from the downloadable protocol list. Now at the device level, really, there's, again, not much to do there. I'm sorry, we're still at the network level. The second stage on the network level is strictly to assign a disable bit, again, so you can reset the network if necessary, as well as a status register where you can monitor the health of the connection to the network. Now we're moving on to the device level. And this is where, just like with MSTP, we need to assign a device instance ID, okay? And that has to be unique. The default is 1, but we would suggest that you select it something other than 1 because there's a lot of devices out there that have a default of 1. Okay, you'll also see that there's a default port of 47808 that's selected. That is a port that typically is used in almost all applications, so you can just leave that alone. In hex, I believe it is BAC0 for BACnet 0. Okay, and then okay, so that's really all we have to do on that side of things is assign the instance ID. Everything else we can leave the same. All right. And I did mention before that the configuration process for assigning the number of objects and the type of objects that you want to support with your BACnet profile is exactly the same between the two variations of BACnet, and that is true here. So again, you can support the same objects with the same limits in terms of the maximum number of each object. Now, the screenshots I've shown you, and I think the demo that I'm going to be presenting here shortly is using register-based addressing for BACnet configuration. that was just the choice I happened to make when I set this presentation up. There's absolutely no problem in using the more modern tag-based ladder approach for configuring BACnet and BACnet IP. So really, I've got on this slide, we're just talking about how the process varies slightly. With tag-based programming, you're going to want to predefine your variables, and those variables that need to be predefined are going to be things like the BACnet status array, which is an array of 4 double words where you can monitor for the health of the connection to the network. The BACnet enable variable that allows you to enable, disable, and reset the network on demand. And then the objects that you are effectively going to be, or the data that you're going to be mapping to your BACnet objects, you'll want to create predefined variable arrays for each of those. So, and that those array sizes are going to match the length of the arrays that, or the length of the number of instances that you need for each of those object types. So for instance, in my example here, if you can tell, under analog values in that dialog box there in the center, I'm showing a variable name of BACnet underscore analog underscore values with a length of 8. So what that basically means is that variable array that I've assigned there in analog variable starting at 0 needs to have a length of at least 8. So that's what I'm referring to there. Now, there's one extra step that when you're talking about communication profiles, that even if you're talking about tag-based programming, that you often have to take. And that is, not only do you have to create a variable, but you also have to map it to a memory location. And that is just because this data is leaving the controller, and we need to make sure that it's mapped to a consistent location and that the OCS always knows when to find it. So with the BACnet driver, each of the different object types, analog values, those are mapped to %Rs by default. Analog inputs are always mapped to %AI. Analog outputs always mapped to %AQ, et cetera, et cetera. So mapping of those particular variable arrays is something that you will need to do even if you're using tag-based programming. Once you're done creating your variables and tagging them or mapping them, if you will, to local OCS address space, then you can go ahead and perform the configuration as you normally would, filling in those variables while browsing the tag database to do so. Okay, now let's spend a few minutes demonstrating specifically how this configuration works, and let's get that started now.
All right, let's take a look at how we configure BACnet IP on the OCS All-in-one Controller. Okay, now I've got a simple application here that I'm simulating. Let's take a look at my screen. I'm simulating doing a simple freezer control here, where I've got a couple of zones in the freezer. I've got a couple set points, and I want to be able to monitor and change set points and those sorts of things from BACnet. So how would we set this up? All right, well, let's start from the standpoint of network configuration. So we need to go into the hardware configuration first. Okay, this is my controller. In this case, I'm using an EXL6W. Let's take a look at LAN configuration. Now, BACnet IP, of course, is an internet or Ethernet protocol. So I've got to make sure that my Ethernet is fully configured. Certainly IP address and net mask at the very least, and I've got those configured here. And then where I configure BACnet IP is actually down here under the downloadable protocols. So I've got this pull down list here, and BACnet IP server is one of my choices. And just like all downloadable protocols, we have 3 levels of configuration that we can do here. All right, so let's start at the network level. Really, at the network level, I just leave everything at default. The only thing I need to configure here is if I'm using Service Pack 3 or later on 9.9, I have the option of assigning a disable bit. So what that disable bit does is it allows me to effectively disable BACnet temporarily and re-enable it again. So one of the usefulnesses for that is in a scenario where maybe I want to reset the port that's allocated to BACnet. One way I can do that is by disabling and then re-enabling using this particular bit here. And then I also have a series of status registers that I can assign. And as you'll see here, it's 4 32-bit registers. The main register we're going to pay attention to is the fourth of those 32-bit registers. That register is going to be counting up when we get good BACnet messages coming into the OCS controller. So that's one we'll pay attention to here. Okay, so that's on the network level. Not much to configure there, but a optional disable bit and a status register or series of status registers. Okay, on the next level, let's take a look at the device level. All right, so BACnet IP. In this case, I have previously added this BACnet IP device here. If I had not configured it yet, I would have to hit the add button, but I've already done that. So I'll just go ahead and double click here and take a look. So here's where we can give the device a convenient name. This doesn't really show up anywhere, it just literally it shows up on the screen only for convenience purposes here in Cscape. The ID is actually the instance number for the BACnet object. Okay, so this is an important number as well. So typically this needs to be unique on the BACnet network. Again, this is the instance number for the BACnet device object. And then the port number, this is the standard port number that's used with BACnet IP 47808. So we can leave that alone there. Now, since we've already assigned a disable bit for the protocol, we really don't need to do that again here. For some protocols, like Modbus, for instance, where we're a master, we'll have the ability to enable, disable the entire protocol, and then enable, disable specific slaves on the network. But because we are a slave on the network here, it doesn't make any sense to configure more than one disable bit, and we've already done that at the network level. Okay, so I'm done here. Now on the third level, which is the scan list level, this is where we go in and we actually configure our object sizes. Okay, so I'm just going to go ahead and double click here. And we configure the object sizes and where they're mapped for each of our different BACnet objects. And remember, the OCS supports, in addition to the device object, which all BACnet devices have to support, it also supports the analog value, analog input, and analog output objects, as well as the digital value, digital inputs, and digital outputs objects. So here we can configure how many instances of these different types of objects we want to support, and then where we want them mapped in our OCS register space. Because this is an external protocol, we do need to assign specific memory addresses here. Okay, so in this case, as you can see, I've assigned, 4 generic word type registers as analog values, analog input type starting at AI33 for, and with 4 of those for my analog inputs, and et cetera, et cetera. Okay, so that's really all the BACnet configuration that I need to do. Now let's go back in and take a look at the key variables, in this case at least, for this sample application. Here, this is where I have effectively assigned my status register, where I can look at the good BACnet message counts counting up. This is where my set point for each of the 2 zones are configured, and I've set those for those analog values that are sent over BACnet. And then these are analog inputs that effectively are going to be sent out over BACnet, AI33 in this case, and AI34. Okay, so now let's go over the network and let's take a look and see what we can find. All right, let's go ahead and explore out over the BACnet network. So in order to do that, I'm just going to go ahead and fire up a BACnet Explorer package. They're available from a variety of different companies. most of which you pay for, some of which have kind of a free version you can try out, and that's just what I'm using here. But this is one of many different BACnet Explorer tools. One of the benefits of BACnet is that you have the ability to explore the network, and a tool like this can effectively, without really knowing anything about the BACnet server out there on the network or a whole series of servers, can explore the network and pretty much discover all that information in terms of what objects are supported, what they're named, all those sorts of things. Okay, so I'm going to go ahead using this tool. I'll just right-click and select Explore Network. Now, I'm just going to be setting up this particular tool. Other tools are going to vary a little bit. So, effectively, I want to go ahead, in my case, just to short circuit the search to keep it limited, I'm going to go ahead and limit it to the instance number, the device object instance number that I know I configured my device for, which was 1. And we did that in Cscape at the device level. It's a local BACnet network. And I'm just going to go ahead and hit OK here. And boom, there it is. It showed up right away, which is nice. You can see the IP address, port number, all that kind of good stuff. Vendor ID, that happens to be the Horner vendor ID. I can then try and expand this device, and it'll ask me if I want to explore the device. I say yes, and now it went ahead and found out all the different objects that our device is supporting. And if you remember correctly, the OCS as a BACnet server has the ability to support analog inputs, outputs, and values, binary inputs, outputs, and values, as well as the device object. Now, you don't have to configure all of these things. You're always going to have a device object. But in our case, in Cscape, we did assign at least one instance of each one of these. Okay? But let's start by exploring the device object. All right, I'll expand that here. All right, and there's some good, interesting information in here. Again, our vendor identifier is 600. Our vendor name, Horner APG. The model name, I'm using an EXLW controller, so that's the model name here that shows up in Cscape. We've got the firmware level available here. What type of device is it? Well, it is a device with an identifier of 1. So lots of good information here on the device. But now we can also go in and explore the other objects. And if you remember correctly, in our freezer application, we were using analog inputs to monitor temperatures. Okay, so in this case, present value of zone 1 is 22.5, there's an implied decimal point there, degrees Fahrenheit. Analog input 34, which is zone 2, has a little higher temperature at the point where it was pulled of 27.3. Okay, which again is an implied decimal point in this case. Let's take a look at our set point for the freezer application demo. Under analog value, zone 1 was set in register 2001. Okay, you can see we've got a value here of 25.0 degrees Fahrenheit. Let's go ahead and change that to 26. All right, I'll do that here. And as you can see, I'll have to read that value in order for it to show up here. And boom, there we go. Okay, so another thing I want to mention here is what these instances of all these different objects are named. As you can see in this case, they are named with the memory location where they are mapped to in the OCS. So that is not configurable. At some point in the future, we'll make those names configurable, but at this point, they're just fixed at the memory location. That's the name, if you will, of each of the instances for each of these different objects. Okay. So that's a quick demonstration of using an Explorer tool to take a look at a OCS controller configured for BACnet IP sitting on a BACnet network.
Okay. All right. So hopefully that demonstration of BACnet IP was fairly straightforward. As you can see, it's not an overly complicated process to configure BACnet. Sometimes trying to describe, how data is represented and how objects are represented and all the different concepts of exchanging data can be difficult to explain. But as you can see, the bottom line is that from a configuration and communication standpoint, BACnet does have quite a bit going for it in terms of, once you actually use an Explorer tool like that, you can get a lot of information just from what's directly reported by the device itself. Okay, let's take a look and see what questions we might have today. Let's see. Okay, so we have a customer here who's very interested in finding out about integrating Z-Wave into the XL series. And Z-Wave is a wireless building automation network. And there are gateways that do exist for Z-Wave and BACnet. But he's definitely got some interest in those sort of applications, so that's good information for us. So we will keep that in mind. Thank you for that kind of comment there. Will the Horner controllers run at a 76.8K baud rate? Alerton or Honeywell is running at a 76.8K baud rate standard. I believe so, but I will double check. Okay, so that is something I'll need to follow up on. Okay, let's see. Are all the device setup steps covered in the programming manual or a supplement? We do have a white paper, a couple of white papers that talk about setting up, doing the configuration side of things for BACnet MSTP and BACnet IP. And a lot of that information actually is in the help file. So if you go to Seascape and you open up the, you open up Seascape, you go into the protocol configuration section where I was showing you where you would add, BACnet IP as a downloadable protocol. When you pull up that first dialog box where it says network configuration, at that point there is a help button which will pull up the help information, and that all that information is actually covered in that separate help file. Let's see. Have you got an example with MSTP? So I don't have it. I didn't. They're very, very similar in terms of the way they're configured. I did show you specifically with a demo, by recording that demo, how to set up IP. Again, the biggest differences with MSTP are really the fact that you have to assign a MAC address, and you might potentially need to adjust some of the token passing parameters. But other than that, it's pretty much the same from a configuration standpoint. Of course, there's a huge difference in terms of performance capabilities of MSTP because it's a relatively slow RS-485 token passing network versus, Ethernet IP or a BACnet IP approach where you've just got a whole lot more bandwidth. So, but otherwise they're pretty similar. Oh, good point here. For some of you, you may notice that in your specific versions of Seascape, that BACnet IP and BACnet MSTP did not show up maybe in your pull-down list of downloadable protocols when you get to that step. Well, that's because we've just recently started including it with the Seascape builds. So if you are interested in running BACnet IP or BACnet MSTP, and when you go to add that downloadable protocol and you find that those files just aren't there, we can get those to you. So our tech support group can send those to you. There's basically a DLL file and a help file, two files that will send you or allow you to download separately, and then you just install those in the appropriate folders in your Seascape directory, and then you'll be good to go after that. So good point there. Is the Horner BACnet certified? We are not. Okay, so I'm sure that's something that we'll be looking at for sure. as the demand for BACnet and our products has grown, and it certainly has grown over the past several months, especially. It's grown over the years, but definitely over the last several months. I'm sure certification is something we'll definitely take a look at. I know that we were scheduled to go to a Plug Fest, but that was canceled because of COVID. So, but anyway, so that's something that we're looking at. What's the speed expected on BACnet IP compared to BACnet MS-TP? Well, from a raw speed standpoint, in theory, it could be as much as 1,000 times faster. In reality, it's just a few hundred times faster. So considerably faster, to say the least, in terms of BACnet IP versus BACnet MS-TP. Can both MJ1 and MJ2 work with MS-TP? Well, we do support the point-to-point serial version of BACnet over RS-232. So if you're talking about a controller that has RS-232 on port MJ1 and RS-45 on port MJ2, I believe they can both be supported. Typically, that's not a problem that we have, is supporting multiple instances of the same serial protocol on multiple ports. But I don't have a 100% concrete answer there, but they should both be supported. Okay, let's see, another good point on 76.8. And obviously, companies that have gone to standardize with MS-TP with 76.8, I'm sure that's just to try and get every last ounce of speed they can out of a legacy RS-45 network, is I'm sure why they're doing that. Let's see, are there plans to add support for user configuration via registers or variables for the device ID, port number, and MS-TP parameters in the baud rate? Generally, the trend has been that we're trying to minimize the number of hard-coded type configuration items and replacing as many of those as possible with variables so they can be done at runtime, as opposed to having to drag Cscape out to reconfigure one of those parameters, even though they don't change very often. So I think that's something that we are certainly looking at for the future, but it's definitely not there yet. There are a few things that you have to hard code still. Okay, I think that's the end of our questions. Thanks for a good list of questions there. And I do have a follow-up on the 76.8 K baud rate, making sure that that's an option that we have. I'll find that out, and we'll try and post that as a maybe in a follow-up email or something. And again, for those of you who are finding that you don't have BACnet MS-TP or BACnet IP available in your downloadable protocol list, we may also include those links as part of an email as well, just in case you don't have it. All right, thanks again for joining us today, and I appreciate your time. Everybody continue to stay safe, and thanks for joining us.